Now, I am going to discuss how to use another very popular non-traditional tool for optimization known as simulated annealing to solve the same problem, like how to find out the optimal design of this particular the single point cutting tool. Now, this simulated annealing its working principle I have already discussed in details. Unlike the genetic algorithm, it starts with only one solution and try to check its feasibility. Now, let us see the statement of this particular problem. Now, here actually I am just going to use simulated annealing to solve the same optimization problem, and as we have discussed that it starts with a process of how to model the cooling process of this particular the molten metal, and on principle it can solve the minimization problem. Now, here we assume some initial temperature at random of the molten metal, and here we have considered T naught is the initial temperature is nothing but 4000 degree Kelvin. An initial solution selected at random lying within the respective ranges. So, B H naught is nothing but 0.02, 0.02. So, this is the initial solution which I have selected, and the termination criteria epsilon is nothing but 0.001. Now, let us assume the following random numbers, because while working with the iteration I will have to use these particular random numbers several times, and I am just going to show only 2 iterations how to proceed with this particular algorithm to determine the optimal solution. Now, given this T naught is the initial temperature, that is 4000 degree Kelvin, and B H naught, that is the initial solution, is 0.2, 0.2. The value of the objective function corresponding to this B H 0 is nothing but m 0 prime is 1572 multiplied by B multiplied by H, that is 0.629 kg. We concentrate on iteration 1. Now, what we do is, so the temperature T 1 is kept equal to 50% of T naught, that is your 50% of 4000 degree Kelvin, that is nothing but 2000 degree Kelvin. Now, corresponding to the random numbers 0.4 and 0.6. Now, if I see the values of the random numbers which you have considered, so I am just going to consider this 0.4 and 0.6. Now, corresponding to the value of this particular the random numbers 0.4 and 0.6, I will have to find out the value for this B and H. Now, how to find out? To find out the value for this particular B corresponding to 0.4, we use this particular the formula, that is B is nothing but the B minimum plus the random number R multiplied by B maximum minus B minimum. So, this particular formula we are going to use to find out what should be the value for the B. Now, here B minimum is 0.005, the random number is 0.4, B maximum is 0.20 and this is B minimum. So, I am getting the value of B is 0.083. Similarly, I can find out the value of H is H minimum plus a random number, that is 0.6 multiplied by H maximum minus H minimum, that is 0.062. So, we can find out what should be the possible values for B and H for the next. Now, once you have got these numerical values, now I will have to check their feasibility, whether these particular solutions are feasible or not, that I will have to find out. Now, to find out that before that actually what we do is, we try to find out the value of this particular objective function corresponding to B h 1, and we substitute in the expression of objective function, that is 1572 multiplied by B into h. So, I will be getting this as actually the value of the objective function. Now, initially your m naught 1, now this m naught 1 actually it was equal to, if I see this m naught 1, so m naught 1 was 0.629 and m 1 prime is 8.089 kg. Now, if I compare, then m 1 prime is greater than m naught prime, that means it is not a good solution, because our aim is to actually to minimize that. Now, based on this particular condition, we cannot select B h 1 as the next solution, and just to give another chance to this particular solution, what we do is we go for the next checking, and the next checking, as we discussed while discussing the principle of simulated annealing, this is based on that Boltzmann probability distribution. So, that particular expression which I have already discussed in detail. Now, the next random number r is 0.7. Now, what we do is we try to find out the change in m prime, that is delta m prime is nothing but the mod value of the difference between m 1 prime and m naught prime, and this is becoming equal to 7.46. And now, we try to calculate exponential of minus delta m prime by t 1, that is nothing but exponential minus delta m is 6.46 divided by t 1 is 2000, and if you calculate this, this will become equal to 0.99. Now, this random number r is found to be less than 0.99. So, we accept this B h 1 as the next point. So, this is the principle which we use. Although this particular B h 1 is not selected according to this particular condition, so we give another chance using this Boltzmann probability distribution, that particular concept, and according to this particular point, that is B h 1, we are going to accept. This completes actually one iteration. Now, we go for the next iteration, but before we go for actually the next iteration, so what you will have to do is you will have to check whether it has reached that particular termination criteria. Now, this termination criteria that is actually is very simple. The termination criteria is something like this. So, what you will have to do is actually we will have to find out the change in m prime, the mod value, that is nothing but m 1 prime minus m naught prime, and if this particular value is found to be less than the epsilon, that means it is a very small value, then we say it has reached that particular the termination criteria. Otherwise, actually we do not we proceed to the next iteration. So, now I am just going to start with the second iteration, and in the second iteration this T 2 is nothing but 50% of this particular T 1, that is 1000 degree Kelvin. Now, before I proceed with iteration, this checking has to be done whether I should go for second iteration or not. Supposing that we have taken the decision that we will have to go for the second iteration. This is how to proceed with the second iteration. Corresponding to the random numbers 0.3 and 0.5. So, we try to calculate B h corresponding to second solution. Exactly following the same principle, I can find out that B is 0.063 and h is 0.52. Now, corresponding to this B h 2, we try to find out what is the value of the objective function, that is m 2 prime. Now, m 2 prime is 1572 multiplied by B h. So, this is nothing but 5.149. So, this is nothing but M2 prime. Now, if I compare M2 prime with M1 prime, we see that M2 prime is less than M1 prime. That means, here this is a good solution. So, what we do? We select BH2 as the next point, and once again we will have to go for that particular checking, that is whether it has reached the termination, and to check that we try to find out the change in M prime, that is delta M prime is nothing but mod value of M2 prime minus M1 prime, and this is nothing but this particular thing. So, we can find out the change in this particular the M. Here M stands for energy, and as it is found to be much higher compared to this alpha, this epsilon, which has been taken to be equal to 0.001. Now, we should go for the next iteration, and this process will go on and go on, and ultimately after running this particular algorithm for a large number of iteration, there is a possibility that it is going to hit that particular optimal solution. Now, this is another very popular non-traditional tool for optimization, and using the principle of this particular algorithm, I can also find out the optimal design of this particular the practical problem, that is single point cutting tool. Now, one thing I just want to mention regarding this particular the technique, that is the simulated annealing. Now, this simulated annealing works based on the principle of one physical phenomena, that is the cooling process of molten metal, and this particular cooling process of molten metal can be modeled mathematically, and that is why a mathematical convergence proof for this particular algorithm exists, which is still missing for the genetic algorithm. So, many people actually relied on this particular algorithm also to solve the optimization problem. Now, another thing I will have to mention here, because this particular practical problem which we are considering, this is one constrained optimization problem, and that particular checking is not yet done. Now, what you can do is, before we declare the finally acceptable optimal solution, we will have to check the feasibility, whether it is going to violate that particular functional constraint or not, because we will have to find out one optimal design after satisfying the condition of that particular functional constraint. Otherwise, the solution is very simple, because B and H are having some minimum value each. So, if you just substitute those minimum values in the value of the objective function expression, we will be getting the optimal design. There is no such actually pressure from other side, and that is why that functional constraint has to be maintained. There should not be any violation of this particular the functional constraint, and we will have to find out the optimal design of this single point cutting tool, so that it becomes light in weight. At the same time, it will have to satisfy the condition that there will be no mechanical breakage during the machining. Thank you.